Piecewise functions are a special type of function that we look into. It has two or more equations within it, and each equation has a specific domain. So it's like I could tell you to graph each of these functions separately, and then I'll ask you to put them together. But instead of separating them into three different functions, I'm just going to write them within one function, and that would be my piecewise function. Now, you might think that is odd, but sometimes piecewise functions just give us a better, more shortcut way of describing our graph or what happens in it. So instead of splitting things up, we put them into one function. So what does this do? It's not as complicated as it seems. Just consider each line as its own function. So 2x is my function, and the inputs are from 0 to 2. And I'm just going to substitute each value in there, and I'm going to get an output. So like you're creating your own table of values, and using those coordinates, you're going to plot in your curve. So if I substitute 0 in there, I'm going to look at this one. I'm going to get 0. If I substitute 1, I'm going to get a 2. If I substitute 2, I'm going to get a 4. Now, you can substitute decimals. They haven't specified if it's all integers. You can, but let's use the nice numbers here. So then you draw your line. This is the first part of the piecewise function. Now, piecewise functions don't look nice in terms of like they're not a straight line, they're not a nice curve. They're going to be disjointed, and that's the whole point. They're pieces together. So then we look at the next one. We're going to look at this function. So for this function, if you've done the basics of functions before, you'll know that no matter what the input is, the output will always be 4. So if my input is 3, my output is 4. If my input is 4, my output is 4, and so on. So I draw my line there. So this line represents the second part of the piecewise function. Notice that I didn't substitute 2 because it starts precisely more than 2, so like 2.1, hence why I've made the line from here all the way there, but this line is still this point, the 2, is part of the first function. And then we continue with the next one. I'd substitute in the values. You could substitute in 4.5 if you want to, just so that you're close to the 4. If I substitute 5, I'm going to get a 4.5. If I substitute 6, I'm going to get a 5, and so on until we get to 8. And that's our second function. So this whole thing is our piecewise function. And it's all a matter of splitting it into different parts and drawing the line for each one, making sure that you stick within the domain necessary. Now, a special type of function is the absolute value. So the absolute value function can be described using piecewise function. Now, what is the absolute value? Just a reminder, it's basically in an informal way, it turns your numbers to positive numbers. So, okay, can't try it. It turns everything positive. So if you have a negative number, it's going to turn it positive, and so on. Now, it can't magically do that. In math, we can't just be like, oh, these magical 2 lines and everything's going to turn positive. We need a more mathematical, clear-cut way of describing that if you get a positive number, the output is a positive number. If you input a negative number, then your output will be a positive number. We need a mathematical way to do that. So what I'm thinking is, okay, if my input is 3, then my output will be 3. So for example, if I'm thinking, oh, my input is 3, well, my output is 3. Nothing changes. Which means that if it's x, it's just gonna spit out x. Now, if my number was a negative, it's gonna turn into a positive. But how do we do that? In math, if you have a -3, what should you do to turn it to a +3? Well, you'd multiply by a -1. Okay, you'd multiply by the negative. So that's what we're gonna do. So if I have an input x, in order to change it to a positive x, I'm gonna multiply it by a -1. Okay, and this might seem a bit complicated, but it's just to explain how the absolute value works. It's just a more complex side of piecewise functions. But going back to this, if you understand this part, that's great. I'm just explaining the definition of absolute value functions. So more precisely, this is what it is. And it's something that you could either memorize or understand. That's completely up to you. So what it basically says is, let's just do a number line here with 0. If my x is from 0 and above, if my input, this is my input, okay? And this is the function. Remember, each line represents a function. If my input is all these positive numbers, then my output will just be the number itself. Nothing's going to change. However, if my input is these negative numbers, then what I'm going to do is I'm going to do this magical negative. I'm going to multiply the negative number with a -1 in here. Okay, I'm going to multiply with a -1, and through this mathematical method, this mathematical function, I'm able to turn my negative inputs, only my negative inputs, into positive numbers. So that's what this line precisely does, is it takes let's take any number, x less than 0, let's take -4. Okay, so my x is -4. And what this tells me is if your x is less than 0, here's what you do with it. Okay, we have so many scribbles. Let's say my x is -4, I'm going to look at my piecewise function. I'm going to say, I'm here. And what do I have to do with my input? I have to take a negative x to it. So a negative x will be a -4, which is a +4. So we have mathematically changed our negative numbers to positive. And that's precisely the definition of an absolute value function. It changes your negative values to a positive, and it keeps the positive positive. And the mathematical way to define that is through this piecewise function. So this is where they're useful sometimes in helping us define specific functions that we need. The absolute value is an operation that we commonly use, but we want to define it more concretely using functions. Now, if you're faced with this type of question, I'm not going to go through it. You can pause and go through it on your own. Notice how in part A you have different functions you need to find, different outputs you need to find. And the way to solve it is just to look at your input, so -1, and you're going to first look at the domain. Which domain does it fit into? And therefore, you're going to use the function related to it. So -1 is in the second line, is in the second domain, so you're going to input it in here. 0 is also in the second one, you're going to input in here. 3 is precisely the second domain, the first domain, so you're going to use the first function for f of 3. You can't use the second function for f of 3. Mathematically you can, but it's not part of the piecewise function. 5 is also belongs to the upper domain, so you're going to input it into the first function, and so on. Once you have all the values, you're able to sketch it, and then you're able to write down the domain and range of the whole function itself.